I get a lot of requests about how to make an ultrasound tweeter. For instance, to repel dogs or animals from the garden, etc., etc. And in this video I want to show how you can make such a circuit, but it's more about development issues, and I want to publish a completely working circuit in the future. Anyway, these are the things that you have to take in account. At first, we have the so-called tweeters with a coil. The coil has a resistance, an ohms resistance between 4, 8 and 16 ohms. Their impedance is low, and here you see how such a tweeter looks like. On the other hand, we have ceramic tweeters. They have in fact a high impedance, so an endless resistance between these two connections, but in reality these ceramic tweeters, piezo tweeters are given on the internet in a situation where they tell that the driver impedance is 8 ohms. I don't know that exactly. I don't know how that works. Here you see my idea about it. There must be a kind of transverter that transfers the low impedant output from the amplifier to that extremely high impedance from that ceramic tweeter. Anyway, you can use, for instance, in such a dog repeller, an audio amplifier that can handle frequencies up to 20 kHz, and then connect to the output 4 or more, or 2 or 1 from this kind of tweeters, and then connect one of the oscillators that's on my YouTube channel that goes to 20 kHz to that audio amplifier from, say, 10 watt or so. But when you want to make it completely yourself, here is a good idea that surely will work. Again, this kind of tweeter is used with a coil, so no ceramic tweeter. Here we have an end transistor. Here we have a voltage, say between 6 and 30 volts. And here we have the driver. That's one of the oscillator circuits on my YouTube channel that goes to 20 kHz or more. The transistor is driven here by that generator. When it doesn't work properly, connect here between the base and the positive lead a resistor between, say, 50 kilo ohms and 1 mega ohms. It's very important that we know Ohm's law. Ohm's law is not completely valid in this case, but anyway, here you see the effects from Ohm's law. The power that's given out to the low impedance speaker at 6 volts, 100 milliampere, and a speaker from 4 ohms, you have 400 milliwatts ultrasonic sound. With a voltage from 12 volt, 1 ampere, speaker from 4 ohms, you have 4 watt output out of this speaker. That's a lot. 24 volts, 0.5 ampere, 8 ohm speaker for also 4 watt. But 4 watt is in fact a quite high output volume for such a speaker, and we have to know that ultrasound is dangerous for our ears. That's important. It's a dangerous frequency. So take some care and read more about it. This is one circuit that you can use with one transistor. But the better circuit is here, and that's a Darlington. This is the Darlington made with the BD139 and the 2N3055 that drives that low impedance tweeter. Driven again at the input via a 15 nanofarad cap. And here again Rx could be between 10k and 3 mega ohm. You have to find it out experimentally. So connect the oscillator here, connect the tweeter speaker or 2 or 3 or 4 of them, and then do experiment with this resistor to get the maximum signal out. When we talk about this transistor TS3, this transistor must be able to amplify approximately 4 watts and the frequency without burnout. And the experience is, my experience is that on ultrasonic sound circuits such a transistor easily burns out due to the excessive heat. That regards also this circuit. Cool that circuit, cool that transistor very well when you drive in here that audio signal. Here we have the practical circuit from the Darlington. And the BD139 here now in the middle of the screen, the 2N3055, and here the pin connections. And here where you can put in that input signal from say 20 kilohertz. And this combination gives the power to the tweeter. Something about piezo tweeter. They are ceramic. Here you see, for instance, how that looks like inside of a piezo tweeter from say 100 watts or so. We have in fact the same circuit and at the same time with a kind of transverter. I don't know that exactly, but it must be there because our audio amp is low impedance and the tweeter is high impedance. Anyway, when you want to connect a ceramic tweeter to an audio amplifier, you can use a capacitor, and that limits the low frequencies that are sent to the tweeter. So that's also an issue. Say you use 10 nanofarad and your tweeter will work. Do some experiments. Perhaps you need 15 nanofarads. Again, piezo, keramic, filter, and there must be a kind of circuit inside such a piezo tweeter to make that it can driven by a low impedant load like an audio amplifier with approximately 4 or 8 or 16 ohms at its output. Anyway, pan over the circuit somewhat. It's not very difficult to make an ultrasound, powerful ultrasound amplifier, and I want to publish on YouTube the circuit in say for a few weeks or so, and I will use these principles, and I'm sure I'm gonna use the Darlington circuit because it gives the best properties, and for ultrasound distortion is not an issue.